Hello everyone, this is section 10.1 for geometry. Circles and the lines that intersect them. So today we're going to be learning about what the definition of the lines and segments that intersect a circle are, and some properties about them. So here's the main thing that you need to know. A segment whose endpoints are the center and any point on the circle is called a radius. We all know what radius is. It's center to the edge. But these are all going to be new. Maybe not diameter, but chord. It's a segment whose endpoints are on a circle. A diameter is a chord that goes through the center. A secant is a line that intersects the circle in 2 points. A tangent is a line in the plane of the circle that intersects in exactly 1 point. And we call it the point of tangency. So some things to know. Radius is from the center to the edge. Chord is a segment that goes edge to edge. And really, we probably shouldn't use the word edge, but you'll understand what I'm saying. Diameter is a special chord. Secant, and here's the difference between a secant and a chord. The main difference. A secant is a line that intersects twice. A tangent is a line that intersects once. So there you go. You've got some definitions. Let's put these into practice. Okay, so it wants to know whether the line, ray, or segment is best described as a radius, a chord, a diameter, a secant, or a tangent. So the first one we're looking at is AC. So from A to C. Okay, let's see. A radius is anything that goes from the center to the edge. Well, there we go. This is a radius. Next, we're looking at A, B. So A to B. Let's see. A radius is from the center to the edge. This goes a little bit forward. Further, a chord is from one edge to the other. Okay, so it is a chord. A diameter is when it goes from one edge to the other and through the middle. Well, there we go. It does that. Then we have DE, ray, DE. And it wants to know, is that a radius, chord, diameter, secant, or tangent? Okay, we know radius goes from the center to the edge. Okay, that doesn't go through the center. A chord goes from edge to edge. Well, there's a problem. D is not on an edge. A secant is a line that goes and intersects the circle twice. Well, let's see. This intersects once. Well, only intersects once. So that means this is a tangent. And finally, it wants to know about AE. AE. Okay, let's see. Radius, nope, doesn't go through the center. Chord, nope, goes past the edges. Diameter goes through the center. A secant touches the circle twice. 1, 2. Okay, cool. This is a secant. Okay, let's just name some other stuff just for fun. I think this is probably the hardest part of the section. It's just remembering all these. And we use them the whole chapter, so this is a really, really important thing. So let's name another radius. Let's name another chord. How about another secant? And another tangent. And I guess another way to name the diameter. Okay, so radius just goes from the center to the edge. So how about CB? A chord goes from one edge to the other. So how about AG? A diameter is just a chord that goes through the middle. So how about BA? A secant is a line that touches twice. So how about EA? It's in the game. And a tangent. A line that touches once. So how about line ED? Okay, there you go. There's your definitions and the practice of how you use them to name. Now, one thing we didn't talk about earlier, but let's talk about now, is how to name a circle. Well, to name a circle, you just use the center. So this is circle C, because the center is at C. Cool. Okay, now two properties we have here is the tangent line to center theorem and the external tangent congruence theorem. Now this one is just a fancy way of saying if you have a tangent, it has a radius that creates a 90-degree angle. So the formal definition is, in a plane, a line is tangent to a circle if and only if it is perpendicular to the radius of the circle at its endpoint. So again, fancy way of saying that is, it's tangent if the radius and the tangent line create a right angle. The other one is the external tangent congruence theorem. And that just says tangent segments form a common external point. Another way of saying that is two tangents always meet at some point that is equal distance. All right, so let's see if we can use these theorems. Okay, so it says, is ST tangent to P? Another way of saying that is ST, this line, and the radius, do they make a 90-degree angle? Well, if I look at this, you know what shape this makes? That makes a triangle. So I'm just checking to see if this is a right triangle. I could use Pythagorean theorem. So Pythagorean theorem is hypotenuse squared equals side squared plus side squared. So if this is true, it is tangent. So let's simplify a little bit. 37 squared is 1,369. Nice. 35 times 35 is 1,225. And 12 squared is 144. All right, 1225 plus 144 is 1369. Nice. So you know what that tells me? Yes. This is tangent because SPT is a right triangle. So we proved that this was 90 by proving that it was a right triangle. Cool. All right. Let's look at this one. So this time it tells us that in the diagram, point B is a tangent, so we must find the radius. So what that tells me is the radius and the tangent form a 90. Wow. Pythagorean theorem. Hypotenuse squared. So what is the hypotenuse here? Well, let's see. I think the hypotenuse is going to be 50 plus r. And it's going to be hypotenuse squared equals side squared plus side squared. So 80 squared plus r squared. And And this problem is really going to test your algebra abilities. So if you remember, this 2 tells me I need to write it twice. And then there's a lot of different ways you can do this. I like to use the box method. Maybe you've seen this before. And now we just multiply everything. 50 times 50. So that's 2,500. 50 times r, 50r. 50 times r is 50r. R times r is r squared. Then we just combine the stuff that's the same. R squared combines with nothing. 50r plus 50r, 100r, and 2,500. And that's going to equal 80 squared plus r squared. So again, let's really test those Algebra 1 abilities. We want to combine the stuff that's the same, make sure it's on the same side. So I want to move this r squared over here and combine them. R squared minus r squared is 0. So r squared minus r squared is 0. Now I want to get the constants together. So I'm going to move the 2,500 to the other side. 6,400 minus 2,500 is 3,900. And then we want to go ahead and divide by 100. So 3,900 divided by 100 is 39. So your radius here is 39. So take a look at this. Make sure you agree. Make sure I didn't make any mistakes. But again, since this is a nice right triangle, it's Pythagorean theorem, just with maybe some nastier numbers than we're used to. Okay. Now, we had one other rule, and that said that two tangents meet at a point, and they make stuff that is equal. So I'm just going to make these two equal. All right, Algebra 1 problem. Get the stuff together that's the same. And last step, do the opposite. We're multiplying here, so the opposite of that would be dividing. Okay, there you go. Really not a lot to that, just make them equal. Don't use Pythagorean theorem here, there's no triangle. No triangle here. Okay, before you exit and go and try the work on your own, do yourself a favor and look at these problems and see if you can get them right. So pause the video and try these on your own. Okay, so hopefully you have answers now. Let's look at this one. Now, number 6 is a little tricky, and it's one that a lot of students get wrong because this is the radius, but so is this. Now it's saying, is DE tangent? So another way of saying that is this a right angle here? So let's check. This is a nice triangle. So we have the hypotenuse, 3 plus 2, 5 squared. And we're saying, does that equal 3 squared plus 4 squared? Let's see, 25. Does that equal 9 plus 16? Well, it does. So the answer is yes, that is tangent because we have a right triangle. Next, it says that it is tangent. So that makes this. So Pythagorean theorem. Hypotenuse squared equals leg squared plus leg squared. Now, I'll just do some speed solving of this. Grab my calculator, make sure I do the correct calculations. And here we go. Get together all the stuff that's the same. And divide. 7. And the last one. These are tangent, so we know these are equal. So 3x plus 7 equals 9x minus 5. Get together the stuff that is equal. And there we go. Okay. So the practice I want you to do on this is some big ideas. There'll also be a worksheet, but we'll probably do that a different day. So let me know what you think. Leave a comment, like, subscribe, and I'll see you next time.